Welcome to Carleton's Math Corner. Today we are going to continue our study on parallel and perpendicular lines. At this time, please make sure that you have your notebook, something to write with, as well as a vocabulary packet. Our target today is the two lines that pass through the two pairs of points are parallel, perpendicular, or neither. First of all, let's just review how to find slope. In the past, in our past unit on slope, we learned that slope is rise over run. And if we find the rate of change in our y-coordinates as well as our x-coordinates, then we can find our rise and our run. So here's our formula for slope, y2 minus y1, and then all over is x2 minus x1. We are going to use that today. So here's the information that we have been given. We have 4 problems to determine if these points, so we have 2 points for each of these lines, and we need to decide if they are parallel to each other, perpendicular, or neither. So let's start off with number 1. We have 2 lines, L1 and L2, and here are the points that they pass through. So let's use our formula and start off with our line number 1. So line number 1, we're gonna use our formula. We're gonna subtract our y's. So we have 12, our second y is 12, our second y coordinate, and then minus our first y coordinate. And then if we take and subtract our x's, we have negative 4 minus 3. So we have 12 minus a negative 2, which is exactly 14. And then negative 4 minus 3 is negative 7. And we can simplify this. It would equal negative 2. So our slope for line number 1, and I'm going to move all this stuff up because we have another line to do, is negative 2. And I'm going to label this m equals negative 2. Okay, so how about our line number 2? Let's do a different color. L2. So let's start off with our y coordinates. So we have 6 minus 2. And our x's, we have negative 3 minus a negative 1. So what do we get? We have 4, positive 4, and over on the bottom we have negative 3 minus a negative 1. Well, that would be negative 2. Nice. And if we simplify this, m is equal to negative 2. Exactly. So if you look at our slopes, what can you say about them? Well, they're the same. They're equal. And so if they are equal, then what does that mean about our lines? Yeah, our lines are parallel. Nice job. So our answer for this one is parallel. And let's just write that. Okay, how about if we look at number 2? So if I take L1 and let's put that back to blue, L1, and let's subtract. So we have 3 minus 2, and it's all over negative 6 minus a negative 3. And what do you get? Well, 3 minus 2 is 1. Whoa, sorry. 3 minus 2 is positive 1. And what's negative 6 minus a negative 3? Right. So we have 1 slash and negative 3. So negative 1/3 is my slope. Excellent job, guys. Okay, so let's compare it with L2 then. So L2 is, we are subtracting L2, 20 minus 2. And what are our x's? Yep, negative 18 and 12. Nice job. Negative 18 minus 12. Whoa! Okay, so 18 minus 12, and so we get 18 on top, and what do we get on the bottom? 6. And so our answer is 3 wholes. Wow. So if you look at this, we have, aren't they complete opposite of each other? So we have negative 1/3 up here, and we have a positive 3. Yeah, so we have what kind of lines here? Exactly. Nice job, guys. These are perpendicular lines. So I'm going to write perpendicular. Nice job. Okay, so let's look at our next one. If we look at the L1, we have we have 8 minus 6. 8 minus 6 first. And then after that, we have 1 minus a negative 1. So what's 8 minus 6? Exactly 2. And what is negative, or 1 minus a negative 1? Yeah, positive 2. So our answer is, what's our slope? Yes, m equals positive 1. Okay, so m equals positive 1. Okay, so let's look at our last one, L2. What's going to happen here? We have negative 4 minus a negative 3. And that would be a negative 1. Okay. And if we put in our x's, we have 4 minus 3. And that would be a positive 1. So what's happening here? If I have negative 1 over a positive 1, then my slope is negative 1. Does that fit in either of these categories, perpendicular or parallel? No, it doesn't. Just because they're opposite sign, I mean, yes, they're equal distance from 0, but just because they're opposite sign does not mean that they are perpendicular, and they're definitely not equal, so they can't be parallel. So no, this one's neither. Neither. Okay, so let's look at our last one. Let's see what category this will fall into. Let's start off with our L1. So if we take 7 minus a negative 3, and what do we get? 7 minus negative 3 is positive 10. Awesome. And then if we do L2, okay, we have 8 minus an, oh, I'm so sorry. We're not even done with L1. Hello. What am I thinking? We still got to figure out our x's, don't we? Negative 1 minus a negative 3. Thanks for reminding me. So negative 1 minus a negative 3 is positive 2. So a slope is 5. Nice job. Now we can actually look at L2. Okay, so we have 2 minus a 7, which is negative 5. Nice job. And our x's, 8 minus a negative 2, and we get 10, which is the same as negative 1/2. Is that opposite of 5? Nope. And I'm sorry, I forgot the negative in there. So it's not opposite though of 5. So that means what kind of slope is this? Or these lines are neither again. They're not the same, and they're not complete opposite of each other either. And so that means we are at neither again. Nice job, guys. We worked through all 4 of those. Now I actually want you to try some on your own. So these are your ticket problems. I would like for you to, determine if these are parallel, perpendicular, or neither. Thank you so much for joining me at Carlton's Math Corner. And I can't wait until we have our next video.